Hi, this is Mrs. Davis. This is AP Pre-Calculus. This is lesson 211. And we are going on the third video, and we're looking at example 5. So example 5 sort of puts everything together. It wants us to sketch the graph of the parent function log 2 to the x. And so you know how 2 to the x's inverse would be log base 2x would be 2 to the x. So if we had, sorry, I should have written this like this. If we have x and 2 to the x, when we put in, if we put in 0, we get 1, and if we put 1, we get 2, and if we put 2, we get 4, and if we put 4, we get 8. And so these are just the inverse of those. So 1 would be 0, 2 would be 1, 4 would be 2, and 8 would be 4. All right, so 0, 1, 2, oh wait, not 4. This is supposed to be, I don't know why I went up to 4. 0, 1, 2, 3, and so this would be 3, 8. 2 to the third is 8. So you can kind of go backwards. This is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. And so these are the normal x's, and these are the f of x's for the exponents. So we can just switch them around. So if you can do it without doing this little chart at the beginning, fine, especially for an easy one like 2. Okay, so we completed the table. How is the graph of negative log x translated from f of x? Well, this negative out in front just means we would be reflected over the x-axis. So now it wants us to make a table of values for g of x, which is the negative of 2 of x. So the x's would be the same, 1, 2, 4, and 8. And this would be 0. I'm looking at these down here now and making them negative. So negative 1, negative 2, negative 3. All right, so then it says, make a table of values, graph g of x on the grid. So now we're going to graph the reflected, and then write the rule. Well, let's write the rule first. Here's how you do it. You would say x, y, and then if you were doing like, you know, what's happening to x, it's reflected over the x-axis, so nothing is affecting x, but y would be negative y. All right, and so now we're just going to graph it. So we're at 1, 0, 2 is negative 1, 4 is negative 2, and 8 is negative 3. Okay, so there we have that. Now this is the graph of g of x. Now it did say at the very beginning, and I missed it, sketch the graph of f of x is log 2 of x. So I'll use a different color to do that one. That would be 1, 0 again, and then 2 is 1, and 4 is 2, and 8 is 3. So that graph looks like this. So this is f of x. Okay. So now we're supposed to analyze f of x and g of x, including domain, range, increasing, decreasing, concavity, intercepts, and asymptotes. So there's a lot here, and you just have to walk through them. So let's do f of x first. And so now I'm going to try to write it how you should write it if you're answering this. So you would say the domain would be from, it would be from 0 to infinity. The range would be from negative infinity to infinity, right? And then it is increasing because the rate of change is positive or greater than 0. It is concave. If you're looking at the purple one, it's concave down because the rate of change is decreasing, and then it has an x-intercept of 1, 0, no y-intercept, and a vertical asymptote at x equals 0. And now if you're doing the other one, g of x, the domain would be same thing, 0 to infinity. The range is negative infinity to infinity. That didn't change. Now it is decreasing because rate of change is, I'll put less than 0 this time. It is concave up because the rate of change is increasing. The x-intercept is 1, 0 again. No y-intercept. And the vertical asymptote again is x equals 0. Okay, so that was quite a lot to put on one question, but very close to what, you could have a free response. So be careful how you answer those questions. All right, now the most important thing this lesson is what's going on right now, because this shows what I need you to be able to do without using a calculator, and it's going to walk you through the steps to solve these problems. Okay, so let's see. Let's use this color. Okay, so it says given the function, determine the asymptotes and end behaviors, and use limit notation for the end behaviors. So first, let's get the sketches done, and then we can answer those questions. For the first one, I have a graph of log x, and then it's translated right 1. So if it was usually at 0, 1, now it's at, 1, 0, now it's at 2, 0. Okay, going in the same direction, and so this is 1, and so my vertical asymptote would have been moved to 1. So we're going to write that the vertical asymptote is x equals 1. All right? Now, we would say the end behavior, you can just look at it. The limit as x goes to, now, it's not approaching 0 anymore, it's approaching 1 from the right of y. I guess we got to use y because they used y as the function letter. So y is equal to negative infinity. And the limit as x goes to positive infinity of y is positive infinity. All right, let's sketch this one. Now you have to rewrite this one because you have a negative x here. So remember how to do this. You have to factor out the negative and just have a positive x, so it would be x minus 2. So that means we have a reflection over the y-axis, and then we translate right 2. So how would this look? Let's do it in steps. So the first one, here's my normal graph. And then I would reflect it over the y-axis. So I'll do that in purple. Okay, it's going to go like that. Now, I have to then move it right 2. So let me use green. There's right 1 and there's right 2. So I'm here, okay, using this graph like this. And so if my asymptote was at, when I moved it, I had it at 0, so now it's going to be at positive 2. Okay, so there we have the vertical asymptote at, you can tell it's at positive 2. So vertical asymptote x equals 2. And then the limit now as x, everything is on the left side, so it's going to be going to 2 from the left. So x going to 2 from the left of y is equal to negative infinity. And the limit as x goes to negative infinity, because I'm on the left-hand side, is equal to positive infinity. Okay? Let's look at C. Again, kind of want to rewrite this a little bit because usually this is on the back side, being a vertical translation. So let's rewrite this as negative log of x plus 4, y equals plus 2. So we see that we have a horizontal translation, left 4, we reflect over the x-axis and we go up 2. So let's look at the graph of that. First we would have our normal graph, okay? And then we're going to move it left 4. So it was at 1, and then 1, 2, 3, 4. So we're at -3 now. So it's looking like that. And our asymptote would be at -4. And then we would move it up 2, but moving it, okay, wait a minute, we didn't reflect it. So now, I'm sorry, we have to reflect it over the x-axis. So now I'm going to use red. I'm going to come down here and be like that, right? That's reflecting that over the x-axis. And then it's moved up 2, which won't affect end behavior or the vertical asymptote. So we have a vertical asymptote at x equals -4, and you can see it matches, right, the horizontal translation. And then we have the end behavior. We're all on the right hand side of -4, so the limit as x goes to -4 from the right of y is equal to positive infinity, and the limit as x goes to positive infinity of y is equal to -infinity. So remember, we're looking at this this graph right here, okay? And one more, we have y equals log x minus 3. Now, you might not even need to write this out because this is not changing anything. It's vertically going down 3, but that doesn't change the vertical asymptote nor the end behavior. So this one is just going to look like going through 1 again. 1, 3, 1, 0. So we have a vertical asymptote at x equals 0, and we would have the limit as x goes to 0 from the right of y going to -infinity, and the limit as x goes to infinity of y is equal to infinity. All right, and so I'm going to stop the video there and go back on the next video and do the one I skipped, which was example 3, I believe.